we're going to look at a second linear relationship. Frankie and Tiffany are siblings that fight a lot. They also steal things from each other. Frankie hides his piggy bank so that Tiffany can't find it. After searching Frankie's room, Tiffany finds the piggy bank and decides to steal money from it. The graph below shows how Frankie's piggy bank is affected by the thefts. Right? So you can see in this picture, there's this linear relationship. Right? And it's pretty much defined for us, but let's write down explicitly what our variables stand for. Right? So this is our x-axis, right? And we can say that x is the number of days after the piggy bank is hidden. And the y, so let y equal the money in the piggy bank. All right, so I like to do that just so we're very clear about what the x and what the y stand for. Right? So as the number of days go by after the piggy bank was hidden, right, the money in the piggy bank goes down because Tiffany stole money out of it. All right, but let's look specifically at what we see in this. Right? And if you look at question A, what we want to do eventually is we want to write an equation that describes the amount of money in Frankie's piggy bank over time. So we want to write an equation for this linear relationship. Right? Well, the first thing I see is the initial value. Right here at the very beginning, right when it was hidden, there was 5, 10, 15, 16, $17 here. This is the point here, 0, 17. So in our t-chart, we can record that. In the very beginning, day 0, there were $17 in the piggy bank. Right? And if we look carefully at our graph, we can see that it's going down kind of slowly here. Right? So this point here is 3, 16. Right? So what does that mean? That means it's after 3 days when Tiffany steals $1. Right? It's going down from 17 to 16. Right? The next point here is, what is that? That's 6, 15. Right? So on the 6th day, it goes down to 15. Right? Tiffany's kind of stealing the money slowly. Right? Maybe she's trying to do it so that she doesn't get caught. Okay? All right, so let's think about our equation. In our previous video, we talked about this idea. Y is equal to B plus mx, right? Where B is the initial value, and then m is the rate of change. Right? Well, we already know the initial value. The initial value was that it started at 17, right? $17. So our y, right, that is the money in the piggy bank, is equal to $17, right, plus this, mx, right, the rate times the number of days in this case. All right, well, let's think about what the rate would be. All right, well, if we look at our t-chart, right, how much is the money changing as the days change? Well, I can see that the money is going down by 1 as the number of days increases by 3. Right? It's going down 1 as the days goes up by 3. Right? Same thing for this one. Right? It's going down 1 as the money, or not, sorry, the money's going down 1 as the number of days goes up by 3. Right? So our rate, our slope, we can use m, is going to be negative 1 over 3, or negative 1/3. Right? And you can see that in the graph. Right? If I were to zoom in here, you can see, let's say, from this point to this point, right, the money is going down by 1 as the number of days increases by 3. Okay? So our slope is negative 1/3. So our equation would be y is equal to 17, right, minus 1/3 times x. Right? So we're starting out with 17, that's our initial amount, and then we're going down by $1 every 3 days. Right? So minus 1/3 times the number of days. B says, how much money will there be in Frankie's piggy bank after 15 days? Right? You can do this a couple different ways. Right? You could use our t-chart. Right? So after, this is going to go down another $1 to 14, and that's going to take 3 more days. to be 9. Right, this would go down another dollar to 13. That would take another 3 days to 12. Right, that we're going to go down another dollar to 12. After 3 more days, 15. Hey, that's what we're looking for, right? After 15 days, there would be $12, right? You can also see that in the graph. I think that would be this point here, right? After 15 days, this is 15 comma 12, right? After 15 days, there's $12 left, right? Still, there's one more way we could do it. We could also use our equation, right? So y is equal to 17 minus 1/3 times x. Well, the number of days, that's the x. So y is equal to 17 minus 1/3 times 15. Oops, let me let you see that. 1/3 times 15 is 5. So 17 minus 5 is 12. Right? So I just showed you 3 different ways to do it. You could have used the t-chart, you could have looked at the graph, or we could have also calculated it. Right? This is the x, so we calculated the y. Right? So after 15 days, there is $12 in the piggy bank. One last one. How long will it take for Frankie's piggy bank to be completely empty? Basically what we're asking is, how long will it take for the money to go all the way down to 0? How long would it take to go all the way down to 0? Right? We could use our t-chart. We could also extend this graph, make it bigger, and see how long would it take the money to go all the way down to 0. Right? I'm going to use the equation for this one. Right? Our equation was y is equal to 17 minus 1/3 times x. All right. So for this one, we want to see when will the piggy bank be completely empty. In other words, when will the y value be 0? 0 is equal to 17 minus 1/3 times x. Right? And let's solve for x. So I'm going to subtract 17 from both sides. That gives me negative 17 is equal to negative 1/3 x. Right? And there's different ways that you can think about this, but what I want to do in this one, I think it's probably the easiest way to think about this, is to remember that this is the same thing as running it this way. Negative 17 is equal to 1x over negative 3. Right? So I'm going to write it this way, 1x over negative 3. Okay? And then to solve that, I'm going to multiply both sides by negative 3. Right? Negative 3 times negative 17, that's going to be 52. Right? And I have these divide out. So I have, it will take 52 days to go down to $0. It will take 52 days for the piggy bank to be empty.